Hey, welcome to the workshop Introduction to Git and GitLab. My name is Julia. I'm in the SFB, and my job is basically to provide the researchers with the tools and the skills to practice a good project management and also to do open science. So for today, we will learn how to use Git and GitLab. And before that, I will give a short introduction to project management and version control to look at the bigger picture. Then we will learn how Git handles the version control, and we will look at the structure of the Git repository. Then we will do the basic Git workflow together, and also look at our commit history and how to do branching and merging. Then we will start working collaboratively, so we will synchronize Git and GitLab and learn how to do basic collaborative work. So we will push our local repository to GitLab, we will fetch and pull from the remote repository, we will fork and clone a project, and also learn how to contribute to a project where we don't have write access. And in the end, I will give a short walkthrough GitLab so that you know what you can do with GitLab, and I will also show you a tonic template for doing project management. So before we start, I just want to point out that to be able to type along, you have to have gone through the preparations instructions, which include to install and configure Git, to set up GitLab, and also download the material for the exercises. Also, this workshop is only going to teach you the very basics of Git to get you started, but to really learn it and that it becomes natural in your daily work, you really have to do it. And if you have any questions, please put them in the Q&A file I put also on this website. And I will look in this file every now and then and try to find answers to your questions. And this way, people can also learn from your questions. Okay, so for the introduction to project management, I want to show you a video. And this video is about a bear researcher and a panda researcher, and the panda researcher wants to reuse the data of the bear researcher. And there are some problems why the panda researcher can't reuse the data of the bear researcher. And yeah, these problems are still a big part of our research work today. Yeah, just take a look at it and then we will discuss it later.
Hello. My name is Dr. Judy Benign. I'm an oncologist at NYU School of Medicine.
Hello, Dr. Judy Benign.
I read your article on B-cell function. I think that I could use the data for my work on pancreatic cancer.
I am not an oncologist.
I know, but I think I could use the data for my work on pancreatic cancer. Do you have the data?
Everything you need to know is in the article.
No. What I need is the data. Will you share your data?
I am not sure that will be possible.
But your work is in PubMed Central and was funded by NIH.
That is true.
And it was published in Science, which requires that you share your data.
I did publish in Science.
Then I am requesting your data. Can I have a copy of your data?
I am not sure where my data is.
But surely you saved your data.
I did. I saved it on a USB drive.
Where is the USB drive?
It is in a box. It is in a box at home. I just moved.
But can I use your data?
There are many boxes. So many boxes. I forgot to label the boxes.
Hello again. Thank you for sending me a copy of your data on a USB drive. I received the envelope yesterday.
You are welcome, but I will need that back when you are finished. That is my only copy.
I did have a question.
What is your question? You might find the answer in my article.
No. I received the data, but when I opened it up, it was in hexadecimal.
Yes, that is right.
I cannot read hexadecimal.
You asked for my data and I gave it to you. I have done what you asked.
But is there a way to read the hexadecimal?
You will need the program that created the hexadecimal file.
Yes, I will. What is the name of the program?
Cytosynth.
I do not know this program.
It was a very good program. The company that made the program went bankrupt in 2007.
Do you have a copy of the program?
I do not use this program anymore because the company that made it went bankrupt. Maybe you can buy a copy on eBay.
I have good news.
You again.
I talked to my colleague. She knew a person with a copy of the software.
Then why do you need me? Everything you need to know about the data is in the article.
I opened the data and I could not understand it.
If you have the program, you will find it is clear.
Well, I noticed that you called your data fields SAM. Is that an abbreviation?
Yes, it is an abbreviation of my co-author's name. His name is Samuel Lee. We call him Sam.
I see. And what is the content of the field called SAM1?
Ah yes, SAM1 is the level of CXCR4 expression.
And what is the content of the field called SAM2?
That is logical if you think about it.
What is the content of the field called SAM2?
I don't remember.
What about SAM3? Is there a guide to the data anywhere?
Yes, of course. It is the article that is published in Science.
The article does not tell me what the field names mean. Is there any record of what these field names mean?
Yes. My co-author knows what the content of SAM2 is, and SAM3. And SAM4.
Can I talk to your co-author?
I'm not sure.
I would very much like to talk to your co-author.
Well, he was a graduate student. He went back to China 2 years ago.
Can I have his contact information?
He is in China. His name is Sam Lee.
I think I cannot use your data.
You could check the article to see if what you need is there.
Please stop talking now.
Okay, so what you just saw is, like I said, unfortunately still the case in research, and it's not only the case when someone anywhere in the world reaches out to you and wants to reuse your data, but this also happens within labs, or also when you want to reuse your data or some analyses you run, I don't know, 6 months ago and didn't do a good job in project management. So the Bear researcher had only one copy of the data on a USB drive that he first couldn't find because it was in some box. So it was really hard to access the data in the first place. Then also the data was in a format that can only be read by this one program, but this program doesn't exist anymore because the company went bankrupt. And also he had like variable names that didn't say anything about what the contents of the variables were, and he also didn't remember what the contents of the variables were because he didn't do a good documentation. And so to not be like Bear researcher, we have to do good project management. And this means a consistent organization for all components of your research project across its whole life cycle. And these components can include data, code, dissemination, or documentation. And so to do good project management, you first should make a research data management plan. You should do that before you actually start working on your project. And write down what kind of data will you collect, how much data will you collect, how will the data be processed, which file formats will you use, and so on. Then you should use open source programs and file formats so that anyone can access your files and doesn't need to pay for some program. You should follow a standardized research folder structure, and that applies to your whole project and also specifically to your data. You should give your files meaningful names and also be coherent in the naming and not name the variables like your co-author's name. You should version control your files. You should document consistently as your project advances, and this also includes the metadata. You should always communicate with your collaborators and of course also share your project, not only the published article, but your whole project. And this you should of course do according to your sharing policies, because if you work with sensitive data, like for example, patient data, you can just not put that anywhere in the internet and everybody can access it, but you can at least share your metadata so that people who would like to reuse your data already know what your data set is about, and can decide if they really want to use your data, and then maybe request access to the actual data set from you. So in this workshop, you will of course learn how to version control your files. We will also do some documentation and communication. We will share the project on GitLab. And in the end, I will show you a standardized research folder structure for your project and your data. So I want to quickly explain where version control comes from, because that's actually important to understand how Git thinks. So version control comes from software development, and software development has like long source codes. It has a lot of code files and thousands of variables because they start their code writing from scratch. So we sometimes do that too, but we also like use already existing functions or processing pipelines and just modify it specifically for our data. But also when we start from scratch, we still won't have like 50,000 lines of code. But this is true for a very, very simple app. They do a lot of testing and debugging. They have these different versions. We all know this alpha, beta, release versions of some software. So they have multiple sets of versions. And they have also many, many people involved because they work according to this modular source code development. So this one person works on this one part of the code, the other person on the other part of the code, and in the end, they merge it together. And so they had the problem that they had to keep track of all the modifications that were made by different people. And yeah, so this is where version control comes from. And I want you to remember that when you work with Git, because our needs as researchers are a bit different than the needs from the software developers. And so sometimes you will find that Git does things in a more complicated way that you would need it to do, but that's done just because it has this background. The benefits of a version control system is, of course, the traceability. So you can track your changes and you can also annotate each change with a message, which explains what you changed and why you changed it. So in the end, you have a complete annotated history of the code. You can also have multiple streams of work, or these version sets I already mentioned, and they can be independent from each other and stay independent, or you can also merge them together on one main working stream. And for collaborative work, this means that all team members are kept on the same page, and everybody can work simultaneously on the same project, and everybody is sure to work on the latest version of the project. So you can use version control for your research work when you do, for example, of course, the code development, but also when you write a paper or to keep track of the changes in your data, for example, raw data, pre-processed data, and so on. Okay, so now we will look at how Git does the version control. But first, I want to say something about the software configuration. So I asked you to configure Git on your machine that you're using right now. And this configuration you have to do once per machine. So for this machine that you're using right now, you've done the configuration. If at some point you will use another computer, then you will have to do the configuration again. The configuration you did applies to all the work you do in Git on this machine. And also, like when you synchronize your work with remote repositories, there, for example, will also be shown your email that you used for the configuration. So it's just convenient to keep it the same, but you also don't have to. And if for one specific project you want to have another configuration, for example, another email, because you're affiliated with another university where you have another email, then you can just run the configuration in this project folder without using that global command. And then you have a new configuration that only applies to this one project folder. And in GitLab, there's something called personal access tokens, and you can use them to make your connection with GitLab super secure. And these you can set up and change and delete anytime you want. And then I already set the words project and project folder. So I just quickly want to show you what I'm talking about when I use these words. So if I say project folder, I mean our whole project, which can contain subfolders and different files. And also when I say project folder, I don't mean the Git repository, so that's not the same. So just want to make sure that you know what I'm talking about when I'm using these words, because I will use them a lot. And then also I want to tell you about a common misconception of Git. So a lot of people think Git and GitLab are the same, but it's not the same thing. So Git is independent of GitLab because Git is a software on your computer and it provides you with a decentralized local version control. Whereas GitLab is a collaboration platform based on the Git software. So this provides you with a centralized repository and distributed version control. So you can use one without the other, but it's just super convenient to use both and keep it synchronized. So this means for this workshop, you will first learn how to use the software Git on your computer for your local work. And then you will learn how to use GitLab and also how to synchronize it with the work you've already done on your computer. Okay, so what does Git really do? So for today, we have the following example. So I asked you to download the material, and this was a folder called Party. Because we're going to plan a party in this workshop. So you now have a local folder that already contains two files, which is the ingredients and the instructions for a guacamole, because we want to have a guacamole at our party. And over time, like during this workshop, we will modify this project folder by making modifications on these two files, and also we will add new files. And when we don't use version control, our folder could look like this one here. So we could manually annotate our our files, our modifications with different version numbers. And then in the end, we will have a folder on our computer, which is full of different versions. Or we can not annotate what we changed in the different versions, and we just keep it named file 1 and file 2, but then we can also not know how our file looked I don't know, 2 weeks ago, when it's, for example, a code file when it still worked and now it doesn't work, so we can't really go back and figure out what's wrong. But if we use version control, we will always only have the 2 files on our computer, and in the background there will be Git, our server computer or version database, which stores the different versions for us, and which we can also like check out anytime we want. So like I said, that's our example, our party project folder. And when you initialize Git in this party folder, then the following happens. So Git provides you a hidden folder, which is your version database, and where it stores your version history, or also called commit history. And Git fills this version database with snapshots. So basically, every time you save the state of your project, Git takes a picture of what all your files look like at this very moment and stores a reference to that snapshot. And of course, you decide when to make this snapshot. So for us, that means we have on our local machine, our party folder, we have our 2 files, and it looks like just a normal folder without Git. So it's the physical representation of the latest version of our file, so what we last saved. And then we have in the background our version database, or the Git repository, and this is filled with snapshots. So if I do a snapshot now, like our folder looks now, it would be ingredients and instructions in their original version. When I modify it, I will take another snapshot, so I will have the modified version of the ingredients, for example, and then I also modify the instructions, so my third snapshot will be the modified version of both files. So you can think of Git as your photographic memory, or also that Git is your prisoner, Sheldon Cooper. He always speaks of eidetic memory, but that's not a discussion for here. Okay, so to understand what's going on and why you have to do the things the way you have to do it in Git, it's important to know how the Git repository looks like. So we have our working directory, our normal project folder party, and then in this hidden Git folder, there's a staging area and your actual Git repository, or also called version history. So when you make modifications on your files, you first have to add those changes to the staging area. So your changes can be added individually. And this is basically telling Git, please hold on to these modifications for now. But adding this updated file to the staging area does not actually save the changes made in the version history yet. For this, you need to commit your changes. And when you make a commit, then Git takes a snapshot of the current stage of your project. And so you can also think of commits as standalone versions of your project. And by making a commit, you're telling Git to please save the current state of the project. So that means it takes a snapshot of how all the files currently look like. And for every commit, Git creates a hash, which looks like this, and we can't really read that. That's really only for Git. And in your commit history or version history, you can find all of these commits, and they can be checked out whenever you want. So now you maybe ask yourself why you have to first add before commit. This is because when you make a commit, Git asks you to give a short description of what this commit is about. And this commit message is always bound to your commit, or also to the hash that Git gives it. So in this commit message, you should describe what your changes are about, because you always add and commit your changes. So for example, you're working on your code file and read the pre-processing steps for some analysis pipeline. And so you change that in your code file by adding these steps, and then you commit them and give it the commit message wrote code for pre-processing steps 1 and 2 according to some paper. So when you make a commit, you should think about the usefulness and the logic of this commit. So if you work on your paper and you just change brain to brains, you should like not have an extra commit for that. That's just unnecessary. So you should always customize what goes into commit. And always remember you add and commit your changes. So for example, you have 3 files in your project folder, for example, 2 code files and 1 manuscript. And then you make a change on the code file. So for example, you wrote a new function and you put the function in the first code file and also in the second code file. So these changes are logically related. So it makes sense to add and commit them together. So you add both files and then commit them to the repository and write 1 commit message, for example, wrote new function. On the same day, you also make changes on your manuscript. So for example, you write the introduction. And this change is really not at all related to your new function. That's a completely different thing. So you should stage this file separately from the other 2 files and make an extra commit for it. So basically what you're always doing is you add your changes to the already existing version or how your project looks like. So you add the changes, you take a snapshot of the current stage of your project, and then you put it in the repository, either your local Git repository or the remote repository in GitLab, for example. And there you also can find your commit message that is bound to that commit that you made. So your basic Git workflow looks like this. You have your working directory, just your normal project folder. Then you initialize Git once in that project folder, which gives you the version database. Then you create files, you modify files, you add them to the staging area, commit them to the Git repository, and then you can do it all over again. So to actually do the things that Git can do for you, Git needs you to know its language, to get a Git repository, of course, to record and commit changes to the repository, and also to still use your own brain. So Git can really do a lot for you and make your life a lot easier, but you still have to have an overview over your project. And this you can do with additional documentation. Yeah. So to get to know the language of Git, here is the vocabulary for the basics of local work. So there's git init. This is to give Git initial control over your files. This doesn't actually make Git track your files or version control them. It just enables Git to version control your files if you want it to. So this is basically just getting this hidden Git folder. But to actually get them version controlled, of course, you have to add them and commit them. And this is also what you do with your changes. So you add a change from working directory to the staging area and commit it. So have your current version of the project saved in the Git repository. With Git status, you can always check the status of the files. That's really useful. With Git checkout, you can check out or also replace a file in the working directory with another already staged or committed version, or you can create a new branch. With git diff, you can inspect differences between versions. With git log, you can view your commit history. And with git merge, you can merge two separate sets of versions or branches into one. So now we're actually going to do that. So I want you to open your terminal. So I also opened the party folder here, but you don't have to do that. I just did that for you to see what happens when we work in Git. Okay, so we first have to navigate in our party folder. So I have it on the desktop, so I can just go here. You can also drag and drop the direction of your folder here after typing cd what's up, whatever is best for you. Okay, so now here we can see we are in our party folder, and now we want to initialize Git so that we give Git the ability to version control our files if we want it to. So we basically just type Git init. And now you can see here in our folder, now there's the hidden Git directory. And also here, it told me that it initialized an empty Git repository in this folder. Actually in this folder, because the Git repository is in this folder. All right, so if we type git status, it tells us we are on our branch main. So that's just the default branch Git gives you. We have no commits yet, which is true. And Git notices automatically that something in our folder is going on, but we actively have to tell Git what to do with that. So it tells us, hey, I noticed there are two files in this folder I'm supposed to version control. Do you want to have it version control? So we want to have that. So we type git add, and we can add the files individually if we want. So we would have to type the file name. But because we want to have both version control, so all of the files in our folder, we can just type git add dot, which means add all the files we have. So now if we do git status again, it tells us we have changes to be committed. And this is true because we just added the files to the staging area, and Git always adds and commits changes. So it handles everything as a change. So Git didn't know our files before, so this is a change for Git. So we need to commit them so that we have the current version of our project saved in the commit history. So we type git commit, and then it opens our text editor, the one that we set as the default editor in the configuration. For me, that's Nano. That's very convenient for working with Git because it's an in-terminal or command line text editor, and you don't have other things open then, but only your terminal. So here we can now type our commit message. First, we have to give it a headline. So we just call this created guacamole recipe. And then we have to press enter to have a spare line. And then we can write the actual longer commit message. And this commit message can be as long as you need it to be. So if you want, you can write a whole novel. Yeah, so we will just write created guacamole recipe for my super party because I really like guacamole. Okay, then we save and close it. And it's actually very important that your text editor is really closed and that it's not still running in the background, because Git sometimes has some problems with that. When it's still running in the background and you make a new commit, then Git might complain. So here it tells us we're on did a commit to our main branch, which is our root commit because it was the first commit we ever made. Here we can see the last 7 digits of this commit hash Git made for this commit. We have our commit headline. It tells us we have 2 files changed, and the 2 files contain 9 insertions. So Git basically just counts the lines in our 2 files. And also it says create mode and then this number, and then this number just says that it's a normal text file. So it's the number for the file format. Okay, so now if we do git status again, it tells us we're on our branch main and we have nothing to commit and our working tree is clean. And so it says that because our files in our party folder look exactly the same as the last version we committed to the Git repository. That's why it says nothing to commit and working tree clean. Okay, so now our Git repository looks like this. We have the ingredients in the first version and the instructions in the first version. If we now want to make a change on one of the files, let's see what happens then. So we just open the ingredients. So because I use nano, I can just type nano and then the file name. If you use another text editor, you can try to use open and then the file name, or you can also just double click on your file and open it. So now we see here in our ingredients, we already have avocados, onion, lime, and salt. But we also want to have 1 tomato. So we insert the tomato here and say 1 tomato. And then we save and close this file. And so if we do git status again now, it says we have changes on our project that are not staged for commit. And it says where the changes are. And it also gives us hints we can add it to update it then and commit it. So that's what we're going to do. We're going to add the ingredients, and we're now only adding ingredients because we only made the change in ingredients. And then we commit it. And then I will call it changed ingredients. Add a tomato to a list of ingredients because I like tomatoes. And then we save, close it. And then it says again, commit to main, the last 7 digits of the commit, hash git assigned to this commit. We change the ingredients in 1 file with 1 insertion. So now our Git repository looks like this. It has the ingredients, the modified ingredients, but the instructions in the original version. Okay, so now that we added the tomato to the ingredients, we also have to update the instructions. So we open the instructions file. And here after chop avocados, we also have to put in chop tomato. So, and then we save, close it. And now let's pretend that we just didn't think about adding and committing that file, and we come back to our project work a day later, and we start by creating a guest list. So because our party, of course, needs some guests, so we're creating a guest list. So again, I can just type nano and then guest list, or you can just create a new file as it works for you with your terminal and text editor. So now we have this new file and we are going to invite Richard and Frank. And we're also going to invite Leah. So we save and close the file. And if we now do git status, it will tell us that we have changes in our instructions that we haven't staged yet. And also we have a new file that is untracked, which is the guest list. Okay, so let's first add the guest list and commit it. And if you are sure that you really only need a very short commit message, like we do now, we just want to say we created the guest list, then you can use git commit -m and put your commit message in quotation marks. For example, created guest list. So I really recommend that you use long commit messages, but sometimes that's really all you need, and then you can go this way. Okay, so then we do git status, and it will tell us that we're still having these changes that are not committed for, that are not staged for commit. So our Git repository looks like this now. We have the updated ingredients, we have still the instructions in the original version, and we have the guest list. So now let's also save our updated instructions. So we do instructions and then git commit. And we do a short commit message again and just saying updated instructions. Okay, so now our Git repository looks like this. So we have the updated, we have the tomato and the ingredients, the tomato and those instructions, and the guest list. That's the last snapshot of our project. And when we do git status again, it says nothing to commit, and our working tree is clean. So again, it says that because how our party folder looks like is the exact same as the last commit in our Git repository. So these two versions, the version in our local party folder is the same version as we have in our Git repository. Okay. So now we want to look at differences, and for this we modify our guest list. So we open our guest list file, and we also want to invite Anna. And so we save and close this file. And then we can use git diff to look at the difference between the last committed version and the version we have now in our local working tree. Because we also invited Anna, but it's only in our local working tree right now. And if you do git diff, then it will compare your last committed version and your version in your working tree. So here the and a guest list shows you how your file in your Git repository looks like, and B is the updated version in your working tree. This is the commit hash, your commit hash, which is in your Git repository, and this is just a number Git assigned to your working tree version for now. And here again, we have this number that says that it's just normal text files. And so here you see your version in the Git repository will be displayed by a minus, and your version in the working tree will be displayed by pluses. So here it says -1, which means the version in your Git repository starts at line 1, and it has 3 entries. The version in our working tree starts also at line 1, but it has 4 insertions. And here it's shows you the exact difference, like what is different in the version in your working tree compared to the version in your commit history. Okay, so now we want to add our new guest list, commit it, the short version that says invited Anna. Okay, so now if we now would do git diff, it wouldn't give us anything because, as git status also tells us, our version in our local party folder looks exactly the same as the last committed version. So what did we do so far? So we initialized the Git repository, we made changes in our project, and we staged those changes for commit. We saved those changes in the local Git repository, and we also inspected differences between the versions of our project. So we looked at the differences between the version in the Git repository and the version in the workspace, but we could also have looked at differences from staged versions to the workspace. Okay, so some comments to this. You should avoid initializing a Git repository within another Git repository. So when you now add subfolders to your project, you don't have to do Git init again. Git will take care of all the contents in your overall project folder where you initialized Git. And you should avoid the nesting because Git could have some problems with that. And to avoid that, you have to have a good project folder structure. You should always write useful commit messages because this is the conversation with your future self or also with your collaborators. Like I said, you always add and commit your changes, and you should always state what you changed, maybe also why you changed it and what this commit is about. The most important thing to remember is unless you add before you commit, those changes are not recorded. So it could be that you add changes on 2 files, but not on the 3rd file, and you commit them, then the change on the 3rd file will not be saved in the Git repository at least. And also, like you saw, Git status is your best friend. It can give you an overview, tell you what to do. It's just really, really useful. And just to make it clear, so far we've only worked on our local computer and nobody has access to our Git repository yet. Okay, so now let's look at our commit history. So what we've done so far and also what branching and merging is. So our commit history is filled with our commits. And every commit, like I already said, has its own commit hash and its own commit message. Hat is a symbolic reference pointing to wherever you are in your commit history. It moves with you like a shadow. So if you want to move in your commit history and go back to earlier versions, for example, hat will move with you and point to the version of your project where you're currently on. That's an expression that you use in Git, so you're always on a certain version. So that's just for you to not lose orientation where you are right now. Also, every commit is pointing to its previous commit. We will see that in a second. And the branch tag always stays with the latest commit made on this branch. So we've only worked on the branch main so far, and this tag will always stay with the latest commit. We will also see that in a second, what that actually means. So our commit history started with that we created the guacamole recipe. Then we changed the ingredients and hat and main moved with us. We created the guest list, we updated the instructions, and we invited Anna. So if you want to see your commit history in the terminal, you can just write git log. And so here you can see all the commits you've done so far with the headlines of the commits and also the longer commit messages. You can see the complete commit hash, and also you can see who did this commit and when. And here, as you can see, head and main are with us right now because we are on the latest version of our project. So main is with us and head is pointing to main because it's always pointing where you are right now in your commit history. If you want to have a shorter overview, you can do git log --1 line. And there you only have the last 7 digits of your commit hash and also only the headlines of the commit message. But also you have the reference to where you are right now and the branch reference. Okay, so we can look at differences, for example, between the version we are currently on and its previous version. So let's do that. We just type git diff, and we are currently on this version, which is the latest version, and we just want to inspect the differences to this version. So we copy this hash and put it here. And then it will show us the difference that we also saw before. So the difference between the latest and its previous version is that we added Anna. We can also look at differences between other committed versions. We don't have to do it from our latest commit. For this, we just type git diff, and then the first commit hash, for example, that we created the guest list. And then we have to type the other commit hash we want to inspect the difference to. And then it will show us that the difference that we made is we created the guest list. That's true, as you can see here. And so it says that the version of the commit created guest list contains these 3 entries, which the previous version doesn't have. Okay, so now, as I said, we can also move around with head. So if we check out to a previous version of our project, head will move with us. So I will show you what that means. So we type git check out because we want to check out this version, like the version where we created the guest list. So we just type git check out and put the commit hash of this version. And so Git tells us, so please pay attention, you switched to this version and we are in the detached head stage. So if we look at our commit history now, we will see that head is with us here at created guest list, but we can see the commits that we did after this. And also main is gone because, like I said, main always stays with the latest commit. And we are at in the commit history where we only had these versions. So the detached head stage is actually a bit dangerous. So sometimes you want that because maybe you want to create a new branch from a certain commit. We will come to that later. But if you do that, you are in the so-called detached head stage. And you could make changes to this previous version. And sometimes you do that by accident. But the changes you make when you are in this detached head stage are not connected to any branch. So let's pretend you just wanted to take a look at a previous commit and you forgot that you were in that detached head stage and you accidentally made changes. If you haven't added them yet and you also don't want to keep the changes, you can just check out to main again, and then your changes are not saved. If you made the changes and already added them but don't want to keep them, you can also just check out to main and the changes are not saved. because like I said, the changes are not connected to any branch, because the branch tag stays with the latest commit and you're currently not on the latest commit. And if you made changes and already added them and also want to keep them, you will have to create a new branch, commit the changes to this branch, check out to main, and merge these branches together. So let's see how we can do this with the branching. So the Git repository can store multiple sets of versions of your project. That's what I was talking about earlier when I talked about this alpha, beta, and release versions in software development. And these sets can live parallel to each other and or be merged together. And one set is called a branch. And a new branch can be created from any commit. That's where I said that's when you want a detached head stage, because maybe you want to create a new working stream from the third commit and not from the fourth commit, because there's something in your code that you don't want to have in your new working stream. And branches can be used in two ways. So it's either movable pointers to work on different development streams. So you can jump between the sets and develop all the sets parallel to each other further. Or you can create a new branch to use it as a pointer to a single commit or snapshot and never move on this branch. And branches can also be deleted. That's something useful, like if you just wanted to try something out and you realize that's not working or not worth keeping, you can just delete the branch. And also the commit history of this particular branch is deleted with it. So for example, this could look like this. So here we have our main working stream. Here's just master, because this Git recently changed the main branch from master to main. And here you can see from the third commit, they created a new branch, the feature A branch. So they were just working on the feature A here. And when they decided that's a good feature, we want to keep that, they just merged it to the main working stream. But they also parallel worked on the main working stream further on something else than on feature A. And then they created another branch for feature B, and this was only had only one commit, and they didn't work on it any further. So they're using it as a pointer to a single commit. So this branch basically only has one commit, and you always know what this commit is about. So it kind of tags or freezes a commit. Okay, so before we create a new branch, we just want to make sure that we are on our latest commit on our main branch. So we can just do git checkout main, and we can control it by doing git --1 line. So we're back at invited Anna, and we are not anymore detached from our main branch. So now we wanted to make a new branch, because we're planning this second party where we want to have other people over. So we're creating a new branch by typing git checkout -b, and then the name of our other branch, which we will call party 1.2. So now it tells us we switch to a new branch. And when we now do git log --1 line, we can see here we are still on the latest commit, which was invited Anna, but hat is pointing to the branch party 1.2 now and not to main anymore. But main is still with us because we created the new branch from this commit. So far, the main branch and the party1.2 branch share the same commit. So this changes when we change something now and add and commit it. So we open our guest list, and we don't want to have these people over on our second party because they already came to our first party. So now we want to invite Howard, and we want to invite Emily, and we want to invite Paul. And maybe we will also invite Billy. Okay, so now we save and close the file. We edit and we commit it by saying, we make a longer commit message actually. We're saying modified guest list and describe it by created a guest list for my second party because I have so many friends. We save and close it. And now if we look at our commit history, it tells us that we moved one commit further on our branch party 1.2, and the main branch stays with this commit. So our version history looks like this now. We are staying with main on the invited Anna commit and move one commit further on our party 1.2 branch because we modified the guest list for this party. Okay, so yeah, so we have everything for our second party, so we can just go back to our main working stream, which we do by git check our main. And we switch to branch main, and if we do git log again, here we don't see the commit modified guest list anymore because it only belongs to our branch 1.2, and we are currently on our branch main. We're just saying main here because we created party 1.2 from main, but it's not true for the other way around. Okay, so we open our guest list again because we actually forgot to invite Joey. And so we save and close, and we edit, and we commit it. In a short commit message saying invited Joey. Okay, so if we do git status, it says we are on branch main. We have nothing to commit, working tree clean. And our version history looks like this now. So because we only modified the guest list for our second party and we like it as it is, we kind of froze this branch or this version of our party because we're not going to work any further with that. That's what I was talking about with you can use branches for freezing a certain state of your project. But there's another maybe easier way to do that, and this is by tags. So if you want to freeze a certain version of your project without creating a new branch, you're using tags. And we will do that for our first party now too, because as it is right now, we really like it. And maybe in the future, we want to use this version of the party again. And then it's just easier to look for the tag than just go through all the different hashes and through the long commit history. So it's just easier to find them. Okay, so we do that by typing git tag, and we are tagging it with party 1.2. And now if we do git log again, we can see we are here on our main branch, and this commit now is named party 1.1. one. And so if we want to find this version of our project again, anytime in the future, we can just look for party 1.1 instead of the commit hash. Okay, so now we will get to know merging. So merging is to merge two committed versions on two different branches together. That's really important. Merging always refers to two committed versions on two different branches. So we want to merge two branches that are both on our local computer. And this is branch party 1.2 and our main branch, because actually we realized that we don't have time to throw two parties. So we only can throw one party, but we of course want to have all the people over. So now we're just going to merge. We want to merge the guest list from the branch main with the guest list from the branch party 1.2. So because we are on our branch main currently, we here have to state party 1.2. So you always have to type in the branch here you want to merge with the branch you're currently on. Okay, so now it says it tries to auto-merge the guest lists because it automatically realized that the guacamole recipe is exactly the same and only the guest lists are different. But it says conflict. It cannot merge our guest lists. So the automatic merge failed, and to fix the conflict, we have to look at it, fix it first, and then commit the result. So now it didn't work, our merge. And why didn't it work? This is because Git merges two branches on a file by file and line by line basis. So file by file, you just saw that it compared the files and realized instructions and ingredients look the same on the two branches. It's only guest list. And then it tried to merge the guest list line by line. It can only do that when the file on the first branch has entries on a different position in the file than the second file. So if you have entries that are not the same on the at the same position in the file, Git doesn't know what to do, because it's different versions and Git doesn't know which version you want to keep. So that's something you have to decide and you have to solve. So explained by squids, you could give the squid a hat and classes, that's fine, but you couldn't give him like two classes or two hats. That wouldn't work. So now it actually tells us it's in guest list. So we are just going to open the guest list. And what you can see here now is that Git tells us where the merge conflict starts. So it already starts here at line 1, and then it gives us what is in the hat, like in the main version, and what is in the party 1.2 version. And so now we have two options. We could either delete, for example, the party 1.2 people or the people from hat, or we're just going to like put them together. So for this, we just have to get rid of what Git put us here in our file. And so to make like one long list of names. And so you could think like Git could have done that by itself, but Git doesn't know what you want to keep and what not, because sometimes, for example, if you get a merge conflict with someone else's work, maybe you don't want to keep the changes from the other person, but rather want to keep your version. And this is, for example, an example when you would delete some of it, but only keep yours. And so Git just doesn't know if you want to keep only some of it or all of it. Okay, so now we have a long list of names. We save and close this. And when we type git status now, it tells us we have unmerged paths, and that we have modified the version of the guest list, and that we now have to add and commit it. So we type git add, and then when we type git commit, it actually gives us a merge commit. This is what it's called, and it also gives us an example of what the commit message could be about. And so we like this, so we just save and close it. And now it says we are on our branch main. These are the last 7 digits of the commit. We have merged the branch party 1.2. So if we do git log now, we can see party 1.2 stays with our modified guest list for the second party. That's how you see we froze this version by this branch. We tagged this version, so the tag is still here. And now we merged the versions. So now on our main branch, we have the version with the long guest list. Yeah. So if we look at our file on our main branch now, so we type cut and guest list, it tells us exactly what is written in our file. Okay, so some comments to this. A merge always refers to 2 versions on 2 separate branches. Merge conflicts are normal, especially when you start working collaboratively. These will appear. There's also some ways to work more slowly and avoiding some merge conflicts. I will show that later. But yeah, they're normal, but you just saw it's easy to solve them. Git tells you where the merge conflict appears and what you can do. You should always think before you create a new branch or tag a commit, because it can be super useful, and you definitely should work with branches and tags. But if you just do them all the time, then it will become too much or also too small, so that it doesn't help you actually anymore. And also, we've still only worked on our local computer so far, so nobody has access to this Git repository yet. Okay, so now we're starting to work collaboratively. And so first I want to give you an impression of what working collaboratively means. So usually it works like this. So we have a collaborative project in which are many people involved, and those people, they communicate with each other, and everybody works on their local machine, and also saves the latest version of the project on the local machine and keeps it there for a while, keeps working on it. And then in the end, they send their newest version by email. But this leads to a lot of questions for the other people, because maybe they also started working on some version, and now it doesn't fit anymore to the version they got per email, or they have questions like, well, you sent me a version 2 weeks ago, is this still the latest version? And things like that. And that's something we don't want. So what we want is that we have a centralized repository, and we use version control to always know what the latest version is. And the people use the centralized repository to update the project and also to get the latest version of the project. And then we have a smooth collaborative workflow. So for example, when we use GitLab as a centralized repository, this could look something like this. So James is creating a new code file, which is for pre-processing some MRI data, for example. So he creates this file and also makes a commit message that says that he wrote the pre-processing steps and uploads it to the centralized repository. Then John gets the latest version from the centralized repository and added some code for some more pre-processing steps, and then updates the centralized repository with his latest version. Then Laura gets the latest version from the centralized repository and notices that there are some bugs, and she fixes the bugs, and then she also brings the latest version back to the centralized repository. And then in the end, Anna just looks through the whole code file and says, well, yeah, that's ready to apply to some data, and puts it back into the centralized repository. So that's a great collaborative workflow. For this, we can use GitLab. So as I said, GitLab is a company who provides you with a remote repository for your local Git repository, and it also has a lot of other functions, which I will show later. For keeping your local Git repository and the GitLab repository synchronized, and to actually benefit from all the things they can provide you with, you have to actively initiate the synchronization. Git does not do that automatically. That's very important to remember. And also everything we just did locally, we can also do in GitLab. Okay, so for working with a remote repository, we actually need some more vocabulary. So there is git push. It's to synchronize your local repository with the remote repository by pushing changes from your local machine up to the remote repository. The other way around is git pull. So you pull updates from the remote repository onto your local machine. Git clone gives you an exact copy of a remote repository on your local computer. Git fetch is updating your local Git repository, not the working directory, with the latest remote version. We can also, again, do git merge. So we can also merge a remote branch with a local branch. And we can do git fork. So you make a copy of the remote repository into a remote repository of yours. Okay, so I just want to explain something about local versus remote repository, which is important to know how this synchronization works. So the local and the remote repository are technically two different things. That's why you also have to actively initiate the synchronization. So the developers of GitLab, they made it really easy for you to keep your local and remote work synchronized, because they adopted the language and the concepts from Git. But there is one important thing to remember for understanding how the synchronization between Git and GitLab works. So Git makes you think you work on the same branches locally and remotely. So they follow the same working stream, and they also share the same version history. But technically, it's handled as if it's different branches. So your local main branch is just called main, but your remote main branch is called origin/main. And this is necessary for the communication between the local and the remote repository to enable functions like merge and diff, because as I said before, like merging is only possible between two branches. So that's just something to keep in mind when you do the synchronization and do push, pull, and fetch, and so on, to actually understand what's going on when you run these commands. Okay, so now we're first trying the push. So for this, we first have to set up a remote repository. So I want you to go to gitlab.uni-marburg.de and then log in. And then if you are not part of any groups or don't have any projects right now, your page here will look a bit different. So your home directory, for me, it looks like this. But you also should see here this button, new project, or you could go on this little plus here and also go here on new project repository. We're doing this, and so now we see create blank project. That's what we want to do. Here you have to like pick where you want to put that project. If you're not part of any groups, you don't have this blank field here. I have to now choose where I want to put this project, and I'm just putting it under my name. And we're going to call that project party because we want to synchronize our party project with GitLab. So in principle, we could name it differently. It doesn't have to have the same name, but yeah, it's just convenient to choose the same name to not get unnecessarily confused. For now, we're going to make a public project, and we also don't want to initialize a README. That's just like for the exercise reason, because then it's easier to do the synchronization. But in principle, you should always initialize a README if you don't already have it on your local project, because that's something where you give information about your project, like what the project is about, where people can find certain things, maybe some links to external storage, stuff like that. Okay. So now we're just going to create a project. Okay, so now it tells us that our project was successfully created. And now we have to somehow get our local work in this remote repository. And for this, GitLab actually tells us what to do. So it says, well, we could just create a new repository locally. We don't want that because we already have one. Here it says push an existing folder that is not yet a Git repository. So we would first have to initialize Git, but we already did that. So for us, this is this option, push an existing Git repository. Okay, so it just tells us we should like navigate in our existing Git repository, and we are already there. I'm not actually. So I will just do that. So now I'm in my local Git repository. Then this command is only if you already synchronized your local folder with another remote repository. So you want to like change the remote repository, but we don't have that, so we can just skip that. And so we have to use the next command, which says we want to add an origin remote repository. That's what the remote repository is called, origin, to our existing Git repository. So we just copy this command and put it here. And then Git doesn't say anything first. But that's fine. And so now we have to push our local work to the remote repository. And we're doing this by this command, git push -u origin all. So we just copy that, paste it here. And then Git does some work. So it says it pushed everything from our local repository to the remote repository, and also the branches. And here it says us, that's what I said before. So the branch party1.2 is set up to track origin party1.2. So that's the remote branch, and also main has its remote branch origin main. So now, because we also created some tags, we have to push them too. So that's the last command here. Copy and paste it again. And so now it also pushed the tag party1.1. Okay, so if we now refresh our remote repository, it should look like this. So now we have everything we have in our local Git repository here in our remote repository. And here we can actually see why it is always important to add your changes individually and to make useful commit message, because here in the remote repository, your commit messages are actually shown bound to the files you made the commit message to. Okay, so here on the left, we can see our branches and tags. So we have everything, that's good. Here under our remote repository name, we have something called commit, branches, tag, and how big our project is right now. So if we click on this commits, we can see all the commits, and here we can see with this ... that we also made a longer commit message. So if we go on this, we will just see our headline, our commit message, and we will actually see the differences between our committed version and the version that it was before. If we now go here to branches, it tells us what branches we have, and if we look at this, then it says, well, our main branch looks currently like this, and if we switch to party 1.2, it looks like this. So here you can say it, or see it changed the commit, because that was the last commit we did on the branch party 1.2. If we go to tags, you can see your tags. And if you go here to graph, you can actually see how our working stream was. So we worked on the main branch until invited Anna. Then we created the party 1.2 branch, made the commit modified guest list. Then we parallel worked on the main branch further and tagged it. And then in the end, we merged party 1.2 to the main branch. So that's actually really helpful to get an overview of your commit history in a bit nicer way. Okay, so that's all for Git push, actually. And so now we want to clone a repository. That's, as I said, cloning is just getting an exact copy of a remote repository onto your local machine. And we're going to do that now, but first, because we're starting to work collaboratively, now we want to, kind of assume that we're working from 2 local machines so that we have a collaborator. Our collaborator is Emma. So I will just go to my desktop and create a new directory, which is called Emma's laptop, so that I know that's the laptop of my collaborator. And so now I go into this directory. And so now I clone my remote repository into this directory. So that's how your collaborator would do that. So you push your work to a remote repository, and your collaborator can just get your work by cloning your repository. So Emma, our collaborator, is now going to get our work. So for this, we have to go on the main page of our project. And here we see this button clone. We click on it, and so GitLab gives us the link how to clone the repository. We're cloning with SSH. So we just click here on copy. And we're on Emma's laptop right now. So here we can type git clone and then paste the link we just copied on our remote repository. And now Git says cloning into parties. So Git actually creates the party folder in Emma's laptop. Okay, So if we now go into this folder, so we are on Emma's laptop in the clone party folder. And if we see, if we make git log --1 line, we can see that we have also our whole commit history back. Okay, so that's git clone. You clone a remote repository into your working directory, which means that also your local Git repository is up to date. So a few things to git clone. If you clone a repository, it will technically clone all branches into your local repository, but only in its remote form except for main. So what I mean by this is, if we do git branch, now we will see we have a main branch, we have the origin main branch, and we have the origin party1.2 branch, but not a local version of party1.2. So if we do git branch, it will tell us we have a local main branch. If we type git branch -a, which stands for all, it will tell us we have our local main branch, we have the origin main branch, and we also have like the origin party1.2 branch. But we don't have this local version of party1.2 yet. That's what I said with that in the background, Git handles the remote branches as different to the local branches. To make the origin party1.2 branch that we already have an actual local branch, we have to check out to origin party1.2 to switch to this remote branch, and then do git checkout party1.2 to make it an actual local branch. So we're going to do that. We're going to check out to origin party1.2. So now it says we are in the detached head stage. And now we're just doing again git checkout and only party1.2. And now it says we set up the branch 1.2 to track origin party1.2. And if we do git branch again now, it says we are on our local branch party1.2, and we have these two local branches. Okay, we're just going to check out to main because we want to work on main further. So now here you can see we switched to branch main, and also now it has one additional line than to earlier, which says that our branch main is up to date with origin main. Okay, so now we're going to make some modification on our party. So let's see where we are. We are on Emma's laptop in the party folder, and now Emma wants to contribute something to our party. So Emma actually wants to make decorations file, because of course we have to have some decorations at our party. So we get some balloons. I don't know if you write it like that, but maybe not, I don't know. And some lights and some confetti. We save and close this file. And now we don't see it here because that's my other party folder. Maybe I'm going to close this now. This will just be confusing. Okay, so we do git status, and it says we're on our branch main. It's up to date with origin main, but we have the untracked files. like it was before. So now we're typing git add decorations and git commit and say created decorations. We also need decorations at our party to make the location look nice. We save and close this. And so here it gives us the same thing as we had before. The hash, the headline, one file change, the number of the text file, and the name of the text file. So now we want to push it back to our remote repository so that we actually, that's from Emma, that we also can see the updates. So we're just writing git push origin main. And it says everything done from main to main. And if we now update our remote repository, we can see here we have our decorations file and we created the decorations like Emma did that. Okay, so now we want to work further on the party with the updates Emma did. So we just have to switch again to our folder. So now that didn't work, I'm sorry. You have to go to up. Yes, so now we're in our party folder again. And now we have to get the updates from the remote repository. And for this, we can do git fetch. Git fetch means that Git is updating the remote branch in your local Git repo called origin main, where it contains the latest remote version of the project. So it does not update your local main branch. It only updates the Git repo called origin main, which is in your local Git folder now. That's also why you can do git merge, because the corresponding local branch main in your working directory contains a different version of the project than the remote branch origin main, which is fetched into your local repo. So it looks like this. You do fetch from the remote repository into your local repository, which means origin main is updated, but not main. And then you can inspect the differences, and if you like it, you can merge it and also update your local main branch. You can then also do git diff because it compares the branch in the working directory with the origin main branch in the Git repository. So let's just do that and see. So if we here do git log --1 line, we see that we are still on the commit merge branch because we haven't updated our local repository with the updates from Emma yet. So we're doing this by git fetch origin main. So now it says it fetched the updates. And if we now do git status, it will tell us we are on our branch main, but our branch is behind origin main by 1 commit. So now we can just look at what the difference is between our local main branch and the remote branch by typing git diff origin main. So we have to type git which difference we want to inspect. So we want to inspect the difference between our main branch we're currently on and the origin main branch. And so it gives you this. So it basically tells us here in the origin main branch, we have a file called decorations with 3 entries. And in our main branch, this file is not there because it says 0, 0. So we have, it starts at line 0 and has 0 entries because the file basically, it simply doesn't exist. So now, of course, we like the update made by Emma. We want to keep this decorations file. So we just write git merge origin main. And it says it did a fast forward merge. That just means that there was no merge conflict. You could just merge the two versions. Everything is fine. So if we do git log -1 line now, we see that we now also have the commit created decorations, which is also the latest commit on origin main and the latest commit on our local main branch. And we are currently here with help. So if we do git status again now, it says we are on our branch main and your branch is up to date with origin main. So our work, nothing to commit, our working tree is clean. Okay, so now we want to update the decorations file. So we open it. And just write, we also need some party hats. We add it. We commit it. Add party hats. And then we want to push it again. Right, it seems as it works. So we update our remote repository. And yes, it worked. We added our party hats. So now Emma wants to get the latest version of our project, of course. So we have to go in Emma's party again. Just checking. Yes, now we're in Emma's laptop party. So another command you can run is git pull instead of git fetch. If you do git pull, it means that you're pulling the version from the remote origin branch directly into your local branch you're currently on, which also means an automatic merge of remote and local version. So git fetch was remote repository to local repository and then merge. With doing git pull, you do everything at once. And that's also the reason why you can't do git diff, because Git doesn't have anything to inspect, as the version in your local Git repository and your local working directory are the same. So it can't inspect any differences here because everything gets updated at once. We're going to try that. We're going to do git pull origin main. Okay, so here that's just, the message Git gave us before, but together. So first we get this message until here, then we inspected the differences, then we merged, and then we get this message. Now you have everything at once because, like I said, git pull is just git fetch plus git merge. We can also see that when we look at our commit history, we already have added party hats. Okay. So let's see what we did. So we cloned a remote repository into a local folder in Emma's laptop. Before that, we pushed our local Git work to the remote repository. Then we did git fetch to get the updates in our local Git repo and merged it with the version in our working directory. And then we did git pull. Okay, so let's see how it is if we get merge conflicts with the remote repository. So now we are in Emma's party. So here she decides she wants to invite someone else. So she wants to invite George. She adds this and commits it. Invited George. And she also pushes it. So now we only have to do git push and don't have to type origin main anymore, because Git already knows what we're referring to, because we did that before. You only have to do it again if you would want to push it to another remote branch. Then you would have to write git push origin and then from the party 1.2 branch, for example. Okay, so let's see. Yes, she invited George. So let's go into our party folder again. Yes, so now we're not in Emma's laptop anymore, but in our party folder. And we don't get the latest version, the latest updates from the remote repository, but we're just working on our party further as it was when we last fetched it. So we also want to invite someone else. And here you see we don't see George because we haven't gotten the updates yet. And so we want to invite Toby. We save and close it. Just looking at it, has it saved it? Okay, yeah. So we add it and commit it. Invited Toby. And so now we're pushing it. All right. So now this failed because it says updates were rejected because the remote contains work that you do not have locally. This is usually caused by another repository pushing to the same rep. You may want to first integrate the remote changes before pushing again. All right. So if you get a merge conflict with the remote repository, it is because you didn't have the latest version of what it looks like in the remote repository. So if you get a merge conflict when doing git push, you first have to do git pull to be able to inspect what the issue is. You could also do git fetch. This would be the same thing here because git pull is going to end in a merge conflict and not doing this automatic merge that you saw before. And if you're doing that, then you can just go on like we did before. So inspect the merge conflict by opening the file the merge conflict is referring to. You change the file accordingly to solve the conflict. So you either delete the things you have in the remote repository, or you modify your file and keep the changes from the remote repository. Then you add, commit, and push it to remote. So we're doing this now. We're doing git pull. And so it says conflict. Auto merging guest list didn't work. So that's why I said you can also do git fetch because you have to inspect it anyway. But yeah, git pull isn't going to work. So in this case, it doesn't matter which one you're using, you will get the same outcome. All right, so it says merge conflict in guest list. So let's just look at the guest list. So like our merge conflict before, Git tells us where exactly the merge conflict starts. And so Toby hat is pointing to Toby because that's the change we made in our local work, and hat is always with us, like I said. And this George is the entry from Emma, which has this commit hash. Right? So of course we don't want to delete George because we want to have Emma also have the people over she likes. So we're just again getting rid of these things get put in our file, and we keep all changes and make one comprehensive list, and we save and close it. So now we do git add guest list and then git commit. And here again, Git gives us an example of a commit message, which says merge branch main of our remote repository. That's fine, we're just keeping that and closing it. And now when we do git push again, it works. And if we update the remote repository, we can see guest list was merged. And if we click on the guest list, we see, all right, we have everything we wanted to have. Okay. So one thing to remember is that merge conflicts only appear if you don't apply your changes to the latest version of your project. So Git told us we have to do git fetch first. So it is a good idea to always do git fetch first when, I don't know, you haven't checked the remote repository for some time. So just doing a git fetch before you start your local work is always a good idea, because then you can do git diff to inspect what changed, and then do a git merge to not run into merge conflicts. But like you said, getting out of the merge, like you saw, getting out of the merge conflicts is also really easy, because Git tells you how to do that. Okay, so now we're going to see how we can contribute to a project where we don't have right access to. So for example, on GitHub, there are a lot of public projects where the owner of this project always also say, well, we're happy if someone could update our project or contribute to this, but you don't have right access, so you can't change anything directly in their project. And how you do this is you have to fork this project. So like I said, forking a project means copying a remote repository to a remote repository of yours. And then you can make modifications on your forked project. You can do that locally or remotely. And then ask the developer of the project you forked if he likes your contribution and would like them to keep to the original. So that's a merge request then. On GitHub, for example, this is called a pull request, but it's the same thing. So for this, I want you to go on the main page of the university GitLab and then search for me. So you will find me here under users, and then go on my profile, and then you should see the project collaborative party, and you click on this, and then here you can see this button fork, and so you should just click on fork, and then it opens this, and then you, like, if you're part of any groups, you have to again choose where you want to fork this repository in. And also you could rename it if you want to, and then just click on fork project. I'm not going to do that for now because I already have it. Okay, then your project page should just look like this one, because you forked it, you have everything I have on this remote repository, you have now in your remote repository too. And then you could clone it and just modify it locally, just like we did before, and push the changes back. Then they would appear in your remote repository, not in mine, but in your forked remote repository. But I want to show you how you can modify things in GitLab directly now. So we just click on this guest list here, and then click on Open in Web IDE. And now here you can just make modifications. So you can just invite someone else. I don't care who. For example, Ida. And then you can click on here, create a commit. And so now it asks you if you want to commit it to the main branch. You're just doing that for now. And here you also get to see what you changed. And then just commit it. Okay, so now if we go back, we say, see, we updated the guest list, or you see the commit message you put in. I just took the default that GitLab gave me. Okay, so now you should go on merge requests and open a new merge request. Here you have to select your branch. So this is your name, collaborative party, and your source branch. If you commit it to main, it's main. And then the target branch, here you should choose mine, collaborative party, and also main. And then you can click on compare branches and continue. So for me, it's an error because it's the same, but you should see the difference to my branch now, and then just click on new merge request. And then if you did that, I will see it here. So for me, it will appear here by your name. And here you can also see I already merged from someone else into my repository. And then if I open this merge request, it will look like this. So here it says I have a merge conflict with this contribution from someone else. So if I want to merge that in my project, in my repository, I first have to resolve the conflicts, and then yeah, I could approve it if I want to, and I could merge it into my branch. And this is how you contributed to my repository without being an owner of this repository and without having write access. Okay. So the workflow for contributing without write access is to fork the repository, and then if you want to work locally, you can clone it, modify it, push it back to your remote repository, and then open a merge request to the original remote repository. Okay, so you should not only work with merge requests when you're contributing to a repository where you don't have write access, but you can also do this on repositories where you have write access. But if you want to have like a nice and a bit slower workflow with your collaborators, you can also open a merge request for your modifications in this repository where you do have write access, just to give your collaborators the possibility to look at what you changed and to decide if they want to keep it or not, and not running into merge conflicts all the time. Okay. Yes, in general, communication is the key when you work collaboratively. Okay, so now I'm going to give you a quick walk through GitLab. So first, there's this thing called group versus project. So you've already seen on my main page, that here I can see all the projects. And if I go onto my profile, it also gives me my groups. So that's the groups I'm part of. And within these groups, there can be the projects or the repositories be assigned. That's basically it. And then you have the general settings for your project name, description, sharing, and permissions, like who has write access, who can give a merge request, how will they be handled, do they have to be approved additional to actually merging it. You can export the project and also set settings for archiving the project, renaming the project, or you delete the project. You will find that under advanced, because of course that's settings that will make a big change to your repository. Here you can also, so let's see, let's go to our party project. Here you can also customize this settings on the left. So if you go under settings, and then the first one, like project features, so you can customize your navigation bar here. You can decide what you want to see here in your navigation list and what not. So for example, I don't want to see analytics, because that's something you usually don't need for your research work. That's something that measures how efficient your team is working. So that's actually more something for, I don't know, companies that also do, like a bigger project management with GitLab. And so if I save this now, you can see that analytics is not anymore in my navigation bar here. So this is how you can customize how many settings you have and see here to make it a bit, have a better overview. Then there's something called code snippets. So these code snippets can also be version controlled, and they can be commented on, and they can be embedded in other apps using HTML. And this is something, like the name says, snippets. It's good for smaller pieces of code that you will reuse over a project several times. So you can have your own code library on GitLab. And the code snippets, they appear in your personal account so that it's easier to use it for projects, other projects. So if you click on your profile again, you have here this called snippets. And so if I had any, they would appear here now. And then I could just assign them to different projects. Then there's the wiki. In this, you can give details on your project. Some advice is that you should there also document which data can't be found on the Git repository. So GitLab can't handle like big data. So if you work with MRI data or something, you can't upload it on GitLab. And then in those cases, you should put just an information in. So the data that is processed with the code we have here on GitLab can be found here, or can be asked for access under this name. And also you should like describe your project pipeline shortly. The wiki is a Git repository itself. You can link pages, upload figures, videos, code, and also export it. Then there's something called packages and registries. That's for the container registry. For example, if you use Docker, you can implement it there. Security and compliance tells you it if you use any libraries in your code, you can connect it to security and compliance. And then this will tell you if there's some updates, for example, on the library you use in your code. Then there's CI/CD, which stands for continuous integration and continuous deployment. These are automated automated pipelines to test your code. For this, we will have a workshop in March. Then the merge request, we already looked at this a bit. So you can give a description of the request. You can give information about the pipelines, and you can comment on the section for discussion threads. And you can also see the lists of commits that are assigned to this merge request. Issues is something for like overall project management. They can be assigned to collaborators and can be integrated to milestones. That's also a term from project management. So if you have like a request, something like, hey, we should really like look at this part of the code. Does anyone have an idea how to work in this? Blah, blah. And then you can assign that to different people. They can answer to that, then they can assign it to you back again. And you also have this a task board where you can pull the issues from open to is assigned and is in progress, or to completed. So this is how you also then get an overview of how your project advanced over time. In the repository, of course, you have your version history. We already looked at it. Your commits, your branches, tags, and your graph. So that's basically it, what you need to know about GitLab for your research work, but you really should just click through the different functions and just try things out. That's the best way to get a feeling of what you can do and what you can't do and how to do it. So some information on the university GitLab. So the huge huge advantage of the university GitLab is, so if you put your project there, the data stays in Marburg on a server in Marburg. So if you put it on gitlab.com or GitHub, that's a server somewhere, I don't know, in the world, I don't know where it is, but then your data is there. And if you put it on the university GitLab, your data just stays in Marburg, which is sometimes something very important. So if you search for project in the university GitLab, you can also only find the project that are within this university GitLab environment. If you set your repository on public, in principle, anyone in the world can find your project and clone it, but not fork it or contribute, because as you saw, for contributing, even without write access, you have to fork it, but to be able to fork something, you have to be in this environment. Your collaborators or contributors you want to have write access to your project have to have a university staff or students accounts from the University Marburg and a 2FA. So you have to apply for an account for this collaborator. You can just contact me in that case, because I actually have to apply for you then. And it's a bit, it's not really complicated, but it takes a while, and you should just know this. Okay, so now we're at the last part of the project, where I will show you one example template for doing good, having a folder structure for your project that people intuitively understand and can get a quick a feeling of what your project is about. So there's something called the tonic template, and it just structures your project in project management files, material methods, data folder, data analysis, figures, your dissemination, and then everything else you haven't put already in the other folders. Your project management files should contain something like your administration files, if some grant is attached to your project, your meetings, data management plans, and so on. In materials and methods, you should put a text file, which gives information that is needed to reproduce the experiments. So for example, like the pipeline. So what do you need? How do you have to handle the code or the data, and so on. Then you should put your stimuli here. And also cross-reference the files like the subjects table or the analysis code, because that's actually something that also belongs to material and methods. But in neuroscience, we want to use the bit standard for data organization specifically. And there you already have like your subjects table. And so that you don't have it double, you just cross-reference it here in this folder, but put the subject table in the data folder. And here you also don't put the code, because that is in the next folder, and your stimuli are already in materials and methods. I'm just pointing that out because if you go look up the bit standard, it says you can also put your code and stimuli here. But that is just if you don't use another structure for the overall project management, like we want to do in the SFB and TAM with the tonic template. So then under data analysis, there you should put your code and also textual description of this analysis pipeline, just to have like a really comprehensive documentation. Then under 5, you should put your figures. And you should, if possible, should use vector figures. And under dissemination, these are the files that are meant for when you start writing your manuscript and other reports. And then, like I said, under the last folder, there goes anything else that you can't put in the other folders because it doesn't belong there. Okay, so I made a template which has tonic and also bits in the data folder as structure. You can fork it there, or you can fork the original tonic research template on GitHub. There you don't have the bits template under data already. And here you can just read about it and have a deeper look at what this is about. Okay, so bits is the data directory structure. It has become very popular in recent years, and they're working on it all the time. So for example, they're planning to release also a data standard structure for eye tracking data now, which is really good for us in the SFB. And basically how you are supposed to structure your data folder. So for example, this, according to the tonic template, would be called data folder. So there you should put your subjects table, like I already said, and then the data is organized per subject. And then under each subject per imaging modality. So for example, if you don't have any MRI data, this would be called behave for behavioral data, for example, if you have that. The derivatives are organized and annotated in the same principles. So if you then pre-processed images, for example, they're just organized in the same way. You should also put the measures of statistics of interest and also the figures and reports. So if you assess the quality of your data set, and these figures and reports you should also put in the data folder under the derivatives. And not in the figures folder of the tonic template. There you should just put the figures that you would put in your manuscript, for example, and not for the raw quality assessment. Okay, so you can read about it all over the internet. There are really good tutorials on it, how to actually use it. And also they made it really easy for you to use it, because there are things called bits converter. So you just get a converter, put your data in it, and then it will give you the data in the bits standard back. To see if your data set is already in the bits standard, you can use the bits validator, and it will tell you, yes, your structure is according to the bit standard, or you have to change this and that to have the bits standard. And then there's also something called bits apps. This is if you have your data in the bit standard, they have like different pipelines, so you can just get your data, put it in those pipelines, and they will handle everything for you. So that's really cool. Okay, so now some final comments to Git and this workshop and everything. So to really learn Git, you just need to do it, and you need to run into troubles and find out how to solve it. Otherwise, you're not really getting ahead of it, because Git isn't easy, but that's okay. So this workshop like gave you the basics of to get started. And if you need something else, then I talked about in this workshop here, then you just Google it. There is so much help over the internet, and this is how your skills with Git will advance. You also don't need to remember everything, because as I just said, there's help all over the internet. We will come to the resources in a second. And of course, like in a collaborative work, the cool features of Git only become beneficial for you when your collaborators also know how to use it. Of course, you can also just use GitLab as a backup of your project, but to really use the functions it can provide you with, it can only work in a smooth way when all people involved really know what they're doing. So besides GitLab, there are many other cool services like GitHub or Bitbucket, and you can also synchronize Git with them, your local working Git with GitHub or Bitbucket in the exact same way as we just did with GitLab. Sometimes there are language differences. So like I already said, a merge request on GitLab is called a pull request on GitHub, but just the same thing. So when you access open platforms of GitLab, like GitLab.com and not the university GitLab or GitHub, and you want to clone, push, or pull, it most likely gives you an error that says can't connect to port 22 or something, because the university network blocks the default port 22. So port 22 is always used to communicate between Git and GitHub, but the university network blocks this port. What you could do is change the port to 443 or disconnect from the university network. I will just quickly show you how you can change the port. So you have a config file, a configuration file for your SSH. This is usually under your home directory, and there's a directory called .ssh. And if you see here, here you have a config file. And if you open this config file, you can put this. You can put host github.com, hostname SSH github.com, and then like maybe you already have this, but if you don't, just put it like this. And if it says port 22 here, just change it to 443, and then it should work. Yeah, if you just if you have any troubles with that, you can always contact me. And then a very important thing, so Git can't really handle binary files. So you can use Git to track them and to push and pull from your remote repository, have backups and commit them and have commit messages where you describe what you changed, but you can't use things like git diff or git merge because Git can't read it. Git can only read plain text. This is true for the text files, for all of your code files. For tables, it's true for .csv or .tsv. So if you're writing a paper and you want to version control it with Git, it's a bad idea to use Microsoft Word, for example. And I will say something to how to version control your paper in just 1 second. Just another things, like if you want to upload large files, for example, videos, you need to enable Git LFS, that's Git large file storage. You can just do that under the normal settings. So here under general and project features, there's something called Git large file storage, and just click on this and enable this, and then it should work. Okay, so about version controlling your paper. So like I said, only text-based, so non-binary files can be handled by Git in all its benefits. So if you want to do git diff and git merge, you can't use Word files. You can tracking the versions, like the updates, like I said, give commit message, I wrote the introduction, and then push it to your remote repository. Your collaborator could pull this version, open it, and look at what you've done, but you can't see the changes. If you want to use a binary file format for collaborative writing, you should rather use, for example, the Hessen box and only Office, or you should use just the version control in Google Docs or Microsoft Office. So they have also this track changes and version control implementation in there. Yeah, so that's how you could write collaboratively on your paper, but then not using Git for the version control at least. Or you can write your paper in a format that is like text-based, for example, in Markdown. Okay, so now some resources at the end. So there is something called Git cheat sheets. This will just give you the basic commands for your day-to-day work and a short description. So if you want, you can download this or save the link and go back to this every time you forget about what exactly you have to put where in which command. Then there's something called oh shit git or dangitgit.com, which is the same, but the letter, if you don't like swearing, you should use dangitgit.com. And that's also like a really, really nice page where you get advice on something that could have went wrong with your project. For example, how to, I don't know, if you did something terribly wrong, how to correct it. Then there's also a comic book on Git, which is really nice, or you could follow the author on Twitter. She sometimes posted some Git comics. Then there's this one woman, she really likes cats apparently, so she explains the Git commands for you with cute cat drawings. Then there's a whole parable on Git. And here's a tool where you can, what you can use to learn Git branching. So yeah, have to use some level, and it tells you, just put this command and do this, and then you can see the working stream and maybe get a better feeling of what you're doing when you're using branching. Okay, so and then there's another workshop coming, which is called GitLab Follow-up. So I will show you how to use Git in MATLAB and how to use Git in R and Visual Studio Code. And also I will show you how you can write a paper in R Markdown, because it's really easy and really cool. And that's a way how you can still use Git for version controlling your paper. And if you have any other wishes for the workshop, you can just let me know and I will try to implement that.